A ballistics testing setup is arranged as shown in a diagram below. A bullet of mass 20 grams is fired horizontally towards a stationary wooden block of mass 2 kilograms, suspended from the ceiling by a long, light wire of length 1.8 meters. The bullet embeds itself into the block and in a perfectly inelastic collision. After the collision, the combined object, which is the block and the bullet, swings upwards as a pendulum, reaching a maximum height where the wire makes a 35-degree angle with the vertical. Calculate the impact speed, v, of the bullet just before it hit the block. So how are we going to answer this question? So there are two things to consider here. One, we have to think of collisions. Okay, so the bullet collides with the block. So because there's a collision, we can use the conservation of linear momentum. So in order to do that, we'd have to know quite a few things. So we are looking for the bullet's velocity before the collision. That's what we want. Calculate the impact speed of the bullet just before it hit the block. So that's the velocity of the bullet before the collision. So if we wrote down our equation, conservation of linear momentum, it would be sum of momentum before the collision will equal sum of momentum after the collision. Okay, so the sum of momentum before, it will be the bullet, I'll just call it m1, and then v1, which is the velocity of the bullet, initial, or we can say before, and then plus the mass of the block times the velocity of the block, initial, that's before the collision, and then that must equal the mass, basically the momentum of the bullet after the collision plus the momentum of the block after the collision. So mass of the block, velocity of the block final, plus mass of the, sorry, that was the mass of the bullet plus velocity of the bullet final. Now it's mass of the block, velocity of the block final. So this is what we are looking for, the velocity of the bullet before the collision. Now we know the velocity of the block before the collision, it's 0 since it is stationary wooden block. So the bullet hit a stationary wooden block, so we know that will be 0 right there. But what about after the collision? So they will be moving together at some velocity. Now the problem is I don't know what that velocity is. So I can easily substitute the mass of the bullet, but I don't know what this velocity is. I can substitute the mass of the block. Again, I don't know what the velocity is. These velocities will be the same because they are moving together. But still, I need that velocity in order for me to be able to have this as my only unknown so I can solve for it. So which means we need to find the velocity of the bullet block system after the collision. Okay, since they're going to have the same velocity, I might as well just remove v2 and just have it labeled as just v, which means I can just take the v as a common factor. Just rewrite the left hand side. So we'll take the v as a common factor. So we have m1 plus m2. So should we be able to find this some other way? Therefore, we can just come back and substitute it here and we get our answer. Now, how can we find the velocity of this bullet block system as it swings? This is just immediately after the collision, right? So it will have some initial velocity just after the collision that will cause it to swing. So it'll start somewhere there, and it'll cause, like, it'll have some initial velocity that will cause it to swing. So we need to know what that velocity is, and it will swing up until it stops there. So we know the velocity at the end there will be 0. Okay, so because it's a pendulum, therefore we can always consider the conservation of mechanical energy. So a pendulum, well, it's treated as an isolated system because we normally don't take air resistance into account. So in this case, yes, we do not take air resistance into account. So this is a perfectly isolated system. So because it's isolated, then mechanical energy is conserved. So this means the mechanical energy while it is there will equal the mechanical energy when it's there. Okay, so let's find what the initial speed was that caused this pendulum to swing up there. So we'll have mechanical energy at A. We'll say down there it's point A and up there is point B. Mechanical energy at point A must equal mechanical energy at point B. Now, how do we find mechanical energy at point A? It's half mv squared. Let me just write down the whole thing. So it's kinetic energy plus potential energy at A must equal kinetic energy plus potential energy at B. So half mv squared, that's how we calculate kinetic energy at A, plus mgh at A, that's how we calculate potential energy. This must equal half mv squared at B plus mgh at B. Now remember, the mass is the combined mass of the two objects because they're moving together as one object. So now we can go ahead and substitute our values. So at point A, basically, call this point A, and you know what, let's just focus on the string here. We'll look at the string as our frame of reference. Okay, so we'll say that is point A and that is point B. So at point A, we don't know what the velocity is. That's the velocity that causes the pendulum to swing. Okay, so we don't know VA squared. Actually, that's what we are trying to figure out. But we know the mass. So 1 over 2, 2,02. Yeah, we had 20 grams and 2 kilograms, so 2,02. MA squared, sorry, VA squared, plus 2,02 times 9,8. Now, what is the initial height? So we're taking this frame of reference as our 0 frame of reference. So our initial height is 0 equals to 1 over 2 times the mass, which is 2,02. Now, as it swings up, it's going to stop there. So our final velocity will be 0 squared there, and then plus 2,02 times 9,8. Now, we have a bit of an issue here because we don't know what that height is. So I'll leave it as HB for now. So now we know that becomes 0 and that becomes 0. So let's simplify. So half times 2,02 becomes 1,01. VA squared is equals to we have 2,02 times 9,8. I'll just leave it as 2,02 times 9,8 HB. I'll leave it as that. So we need to get what HB is. What's the height over there? Now we need to use the length of the string. So we are given the length of the string is 1,8. So we know this is 1,8 meters. Now this means this length here is also 1,8. So let me just give myself some space. So this length right here is 1,8. If that's 1,8, therefore I can construct a triangle here, right angle triangle, and I can find what this length is. Okay, let's just use a different color here. So I need to find what this length is. So we can just use simple trig. So this is the adjacent side, since I know this angle. So that's the adjacent side. And then that's the hypotenuse, so I use cosine. So therefore I'll have cosine of 35 is equals to the adjacent side, I'll just call that x, over the hypotenuse, which is 1,8. Therefore x is equals to 1,8 cosine 35. So that is 1,8 cos 35. So if this is 1,8 and that's 1,8 cosine 35, therefore what is this difference here? Well, it's simply going to be the 1,8 minus that. Okay, so that would be the height. That's the height we are looking for. So HB is equals to 1,8 minus 1,8 cosine 35. So let's substitute it back into this equation. 1,01 VA squared is equals to 2,02 times 9,8 times 1,8 minus 1,8 cosine 35. So we can now solve for, the VA, which will come down to 2,526. So I'll round it off to 3 decimal places for now. Meters per second. So this is the velocity, the initial velocity as it swings up. But remember, this velocity as it swings up, the initial, is the velocity after the collision. So now I go back to this formula here. The velocity just calculated is actually this velocity there. So therefore, let me just rewrite my equation. M1 V1 initial plus M2 V2 initial is equals to V M1 plus M2. So now I can substitute everything. So this is for the bullet, and I'm looking for V1 initial. So that's the block. Now, initially the block is stationary, and then that's the velocity that I just calculated. And then this is 2 plus 0,02. And then it becomes 0. Sorry, this is plus. Yeah. So yeah, that becomes 0. Then I just find what this right hand side divided by 0,02 is. So it's going to be 255,1213 meters per second. Now I could have made some mistakes, like some rounding errors or mistakes on the calculator. So just be sure to double check these numbers. But the method is fine. So this is how you can solve a bullet block system like this.